Hello guys, I'm Felix Landaeta. As part of the requirements for the fellowship application, I decided to make a video regarding a project I developed a couple of years ago. A project I named Sterilization Washing Trays for Needles and Peripheral Parts, Hose Connectors and Flow Regulators. The project was developed for a pharmaceutical company located in Puerto Rico, a pharmaceutical that was filling vials under a sterile condition, meaning under an isolator. While filling, the customer needed to make sure that the needles and the peripheral parts were fully sterilized. Needles and peripheral parts are made out of stainless steel 360L. The peripheral parts consist of hose connectors and flow regulators. All parts are very fragile, especially the needles, and all parts come calibrated on some critical dimensions such as concentricity and inside hole diameters. In order to satisfy sterilization requirements for sterile filling operation, the customer needed to follow these steps. Manually washed each needle and peripheral parts. Build a batch of 24 sets. Place the sets into a metallic basket to be submerged into an ultrasound bath. Then move those sets into a chemical wash and from the chemical wash into an autoclave. So finally, the parts were ready for integration to the filling isolator for a final assembly. While sterilizing the needles and the peripheral parts, the customer was encountering a very interesting problem. The needles got usually bent, affecting the concentricity of the assembly and thus, lastly, impacting the filling process by not being able to align the needle with the vial. Also, the customer was finding that some parts, needles and peripheral parts, were being lost during the sterilization process, thus impacting the integrity of the sterilization batch. The problem was simple then. The customer needed to develop a fixture or a device capable of protecting the needles and protecting the hose connectors and the flow regulators, the needle from being bent and the other part from being lost during the sterilization cycle. By allowing this, it was completely capable then to have an integral assembly to be introduced into the isolator. Whatever device or fixture we were going to develop for the customer needed to comply with all FDA regulations that apply for fixturing that is going to be used under a sterile application, a sterile filling application. So it needed to comply with FDA. It needed to be, of course, safe to be used by one operator without the assistance of any mechanized gadget. It needed to be robust as to withstand the cleaning process itself. It also needed to be a whole unit, meaning that it couldn't have any assembly parts in it. So we came up with the following solution: a tray, completely made out of stainless steel 360L, capable of holding at least 24 sets of needles and peripheral equipment, with a maximum contact between parts and the cleaning of sterilization agent, easy to use, transport, clean, and capable of allowing a fast and robust accountability of parts. The manufacturing process consisted of a milling-based CNC approach, with all welds made under a sanitary protocol and all surfaces polished to RA less than 15 nanometers. As you can see from the last pictures, we achieved a working prototype. The client ended up purchasing over 20 more assemblies, which are currently being used. I hope you liked the video. I hope to see you soon in Minneapolis. Take care. Bye bye.